welcome back to the show. I'm happy today to be talking with Elaine Ingham. Uh, I have a hard time pronouncing her last name for some reason, but I'll get it by the end of the show, I'm sure. She's like a big role model for me. I've been following her content for already quite a while, and I probably have seen every single one of her podcast interviews like 3 times over. So, especially when I was trying to learn more about the soil food web, I feel like you're a great resource that simplified a complicated issue into like understandable terms. So thanks for putting all that content out there and spending a lot of basically your whole entire life trying to master that area. And so I appreciate it. So welcome to the show.
Yeah, glad to be here. And thank you for inviting me very much. And it is Ingham. You
Ingham,
keep
yeah.
trying putting an
I got
R in
yeah,
there.
I got it right before the show when we were trying to practice it, but then obviously it
In
was
the stress of the moment.
yeah.
Yep.
Ingham. Okay.
Yep.
Okay, cool. So I have like a few topics I would like to cover with you today, just some general big picture topics and then kind of some smaller issue topics. So let's dive in. I'm going to have the doctor's extensive resume in the description. It's probably going to take like the whole entire podcast episode just to go over all the accomplishments. So I'll leave that for the description if anyone is interested. But yeah, I wanted to kind of get a bigger picture overview. So first, like, what do you feel like the state of crop production in the U.S. is like these days? Do you feel like it's kind of getting better or getting worse in terms of like producing soil quality and quality food in general?
It's hugely better. So when I was doing my PhD, master's PhD work, Colorado State, large ag campus, and you could just see the problems getting worse and worse all the time. So that was, gosh, I earned my PhD back in 1981, which kind of gives you an idea of how long ago that was. And when my major professor gave me my project that he wanted me to do, to develop a way to assess active fungi, total fungi in the soil. Um, he had me go around to all the other departments on campus that had to do with soil. So like crop science and, the greenhouse folks, the hydroponics people, um, the agronomists, Department of Agronomy, all of those kinds of places, and sit down and talk with the professors in those different departments. And to a person, they said that there was absolutely no reason to study organisms in the soil,
Mm-hmm.
that they didn't really have a role and function, and that the only way we could feed the world was to use the pesticide, inorganic fertilizer, the toxic chemical approach is what I like to call it. Uh, and today, most of those people have retired or they're dead. Today, the people in their positions are much more likely to say, yes, we do have to keep an eye on the microorganisms. We have to have the biology. We've got to have the organic matter. So it's a huge step in the right direction to have the people in academia saying this, to have large grower groups dependent or using inocula of microorganisms into their agricultural fields.
Mm-hmm.
Unfortunately, they haven't quite grasped the whole situation, and that's what we at Soil Food Web are doing, is trying to get people to understand that you're not even going to begin to get the diversity of microorganisms in your soil that you have to have in order to make it work, when all you're putting back into that almost completely dead set of dirt that's actually out there in your agricultural field. If you're only putting 2 species of bacteria back into your dirt, it's not going to last very long. All microorganisms are selected by temperatures and moistures and nutrients and foods that are present, and think on a day-to-day basis how those things change and are different from day to day. You get a weed growing here, you get a dandelion, and you're going to get a different set of microorganisms. If you've got an early successional grass species, a completely different set of foods, and therefore almost completely a different set of microorganisms growing around that root system. So different weeds are going to be selecting for different sets of microorganisms. So you put two microbial species into your soil, and you will probably notice a difference because it's better than having two less organisms in your bag of tricks. But the benefit from those two species of bacteria is not going to last for very long.
Mhm.
And every place is going to be inoculated with those two bacteria. And now you're still at a really low level of production. Your plant material doesn't have the nutrients in it. Because, of course, who does nutrient cycling in the soil? It's the biology. It's the bacteria and the fungi being fed by the exudates coming out of the root system of the plant. And the plant has only had, about 1 billion years to figure out the relationships. What exudates do I need to put out when I need cobalt? What
Mhm.
is the exudate I need that I put out when I need nitrogen or phosphorus or magnesium or calcium? So it's a very complex system when you start getting down to the nitty the gritty. It's a very easy to understand system when you realize it's just simply the plant is putting out the foods to feed the organisms that will go get what the plant needs.
Mhm.
We don't have to be messing with that system. The plant knows what it needs. When's the last time you talked to your plant and you said, "Plant, what do you need today?" And your plant said, "I need 10 nanograms of calcium." Has never happened that way. So
Mhm.
let the plant be in control of its own life. So you put it, the plant puts out the exudates, it grows the bacteria and fungi it needs. Those bacteria and fungi produce the enzymes that pull the nutrients out of the sands, the silts, the rocks, the pebbles, the clay, whatever you've got in your soil. Organic matter is just like a great big piece of icing on the top of the cake.
Mhm.
Makes things work faster and more easily. You're going to have greater diversity. And then the bacteria and fungi have to be eaten by protozoa or nematodes or microarthropods or earthworms. And when they are eaten, the concentration of nutrients, of every single nutrient, is so much higher in the bacteria and fungi that they are releasing a massive amount of those nutrients that your plant needs. And of course, the bacteria and fungi are right in your root zone.
Mhm.
So that when they get eaten, those nutrients are bang right there for your root to take up. Thank you. Doesn't have to wait for a diffusion gradient to get the nutrient to the root system. There's no effort on the part of the plant. It just appears where that plant requires it. So it's a much simpler, easier way than putting on inorganic fertilizers, where 80% of most inorganic fertilizers that are applied are lost out of the soil and they end up in your rivers and streams and lakes and ponds and destroying water quality. So what's the quality of water that's coming out of your tap? It's gone way down.
So
So
you're telling me Mother Nature knows a little bit more than these chemical manufacturing companies? That must be a lie. I heard a different one.
I know
A
it's
billion years, that's not enough education, you know? Gotta trust
she's
this
been
guy that's
fooling
been
around.
for 10
And
years, that's come up with this formulation and he knows best, you know?
yep, and especially the damage that everybody can see
Yeah.
to those chemicals being placed on agricultural fields. They don't stay in place. They don't feed your plant. 80% of what you're putting on does not go into your plant. Wouldn't a wiser way to be to grow up a whole bunch of bacteria and fungi and protozoa and nematodes, all the things your plant needs, and have that sitting in a pile someplace on your farm, ready for those organisms to be put back into that soil when you detect that there's something lacking? Yeah, and it's called compost.
Mm.
You have to compost correctly. You can't follow the 50% manure, 50% straw, I'm sorry, that will never make compost. You've got to add other materials. You've got to have higher diversity. And so we have devised a very simple recipe for people to be able to use. And as long as they follow directions about time and temperature and turning, they'll be able to make good compost themselves. You want to get into some of the highly specific relationships between what has to be in that compost. If you're trying to grow avocados, for example, it's not what you want to be putting in if you want to grow tomatoes.
Hmm.
So different diversity, different sets of microorganisms. Please devise your compost such that it selects for the plant that you want.
Are still most crops being produced, even regardless of corn and soy, being produced through like monocropping still? Is that like the predominant, like in terms of total pounds produced, is that the predominant farming system still to this day?
Yeah, in the U.S., yeah, and much of the rest of the world, Brazil, South Africa, all the large areas, Malaysia, Puerto Rico, or um, all of those countries. When you get to large scale agriculture, it's all monocrop
Hmm.
because they just this is easier. And I always kind of shake my head and I say, no, it's not easier to have a monoculture because how are you going to take care of the weeds? Especially if you're actually farming with dirt instead of soil. There is no way to get rid of the weeds because you have set up a system that is perfect. Those are the conditions that Mother Nature sends in the weeds. And so she's going to be saying to the weeds, hey, go do your duty. Get out there and get that soil covered, get that dirt covered, actually. And so we should use this to our own benefit. We should be putting out cover plants that support the growth of the plant, the crop that you want. And that way you have complete coverage. There will be no erosion. There will be no loss of your soils washing down the hill. You won't be losing soluble nutrients out of your soil. So if you wanted to use an inorganic fertilizer, although it's absolutely unnecessary to use inorganic fertilizers if you've got a good, healthy food web. But if you just felt the overarching need to get out there and waste your money, because you're paying for the inorganic fertilizer, you're paying for the equipment, you're paying for the salaries of the people applying. Tell me that that doesn't cost you a pretty penny. It's not the cost of the fertilizer that you really have to think about. It's the cost of applying it to the soil. If you wanted to, put out your inorganic fertilizers on those cover plants and they'll suck up those nutrients because they're supporting the bacteria and the fungi and the protozoa and the nematodes. You just can't be putting out too much inorganic fertilizer. So you've got to be really careful when you're dealing with these toxic chemicals. And yes, most everything in the chemical in agriculture is still monocropping, and we've got to deal with that. All of these other approaches to growing plants, organic and biodynamic, and I don't always remember pull the names out. All
I
these
have them
different
written.
ways.
I always forget too, but I always write it down. There's like a million of like permaculture is a popular one, 1,000,005 different farming systems these days. So it's hard to remember all of them.
Yep, it's hard to remember them all, but they're all going to work better if they have the right biology in the soil. So all these alternative methods of raising crops, um, you're probably getting a better quality of food.
Hmm.
You're getting more nutrients and more and varied kinds of nutrients in those crops produced not using inorganic fertilizers and not using pesticides, because all of those inorganic fertilizers are killing the beneficial organisms that will prevent diseases, prevent problems in the root system, prevent the bad guys above ground, the insects, from attacking. And they cycle nutrients and they build soil structure so your roots can go down further so you don't have to water in the middle of the summer, because your roots are getting down to that water that's at 10 feet, 15 feet, 20 feet. People have been astounded when we've gone out and at the end of the growing season, we ask them to dig up the roots of their corn. And they go down and down and down. And some of those roots, a majority, I'd say that the roots of corn go down somewhere between 8 to 12 feet. But there have been times where we've found corn roots down at 15 to 20 feet. It just depends on how much water did they need and where were they chasing that water, where were they chasing nutrients. And so the roots will go down as far as the roots need to go to supply the demands of the plant. And so it's going to be really important to get rid of all of those compaction layers where water is held, it puddles, it goes anaerobic, and now you're going to kill your roots if they get anywhere near that anaerobic area. So roots are obligate aerobes, and people seem to forget that. Well, we're going to put this anaerobic tea out. Well, guys, you don't have any nutrients left to speak of in that anaerobic brew because under anaerobic conditions, the anaerobic bacteria convert many of your nutrients into gases and they blow off. So, well, now where are you going to get your nutrients from? You're totally dependent once again on the biology in the soil. However, those organisms that utilize the exudates coming out of the root system of plants are aerobes. And if they were anaerobes, they would be killing your plant. So not a combination you want to put together. You want aerobic organisms, you want aerobic teas to help replenish those sets of organisms so that you're going to maximize nutrient cycling. You're going to maximize building soil structures so the roots can go down as deep as they need to go.
Do you feel like it's at all, I know maybe in some cases on paper it's possible, but do you feel it's at all possible to grow like a healthy monocrop that maximizes the nutritional profile of the specific crop in question?
It's going to be hard because you're talking about bare soil in
Hmm.
that case. So if you have only the crop, the single plant, and they've got to be spaced far enough apart so that those root systems can get to the nutrients that they want, um, you are now subject to erosion. You're subject to evaporation if it's a really dry summer. As your water comes to the surface of the soil, it's going to leave behind all of the salts. And so now you've got an encrusted salt layer. Great. What's that going to do to the growth of your crops? You're going to have the problem with weeds because where you've had to till and till and till, you're killing organisms. The good guys are being killed every time you till. Probably on average, in general, the number would be 50% of your beneficial organisms are killed each time you till. So to get that soil just perfectly tilled and plop in just your desired crop, you've set up a condition in that soil that selects for the weeds to germinate and grow. So fungal to bacterial ratio, all those fungi have been sliced and diced and crushed. The bacteria have gone bonkers because you've broken up all the micro and macro aggregates in that soil. So all of those food resources are available to the bacteria at the beginning of the growing season, and they just go crazy.
Mm.
And it is perfect for getting the seeds of the weed species to germinate and grow. You have made a problem for yourself under those conditions. So why do it? Put
Mm.
in an understory. If you don't want to put in short, low growing plant species, then mulch. But you might have to go back out and put on another inch or so of a mulch layer in 2 or 3 weeks because the biology in the soil is just so ravenous for any kind of food to eat that it's just going to cause that um, layer of organic material at the surface of the soil to just almost instantly decompose. I've seen in some places when we worked down in Mexico, in hot, dry climates, that layer of organic matter is gone in 3 to 5 days. So now you got to be out there and put on the next layer of organic matter and the next layer. And it's it's an expensive proposition once again. And how can you be driving your tractors or your trucks or whatever you're using to haul the organic matter out into your field? How are you going to prevent compaction? Well, you compact the soil, your plant's roots can't get into it because it doesn't have oxygen. So what's the damage? What's the harm to the plant? You can have dead plants or plants that are so weakened, so stressed that they can't resist diseases. They can't resist the pests. And now you have a crop failure. So lots of things to consider. I'm kind of going way off on a lot of things
No, this
there.
detail is good. And for the listeners, you can correct me if I'm wrong, but pests are basically nature's way of getting rid of weak plants. So typically, if you don't have like weak plants, the pests aren't going to come around anyways. So obviously, when the pests come around, you need the farmer would typically use a lot more pesticides, which hurts the soil like even more and creates that like vicious cycle and makes weaker plants. Then you got to use more and more, et cetera, et cetera. You did mention bacteria and fungi a couple times as setting the foundation to the entire soil of food web, basically, and it's very specific to the crop at question. Like every crop has like a specific ratio of bacteria and fungi to that crop to help maximize the health of that crop. Uh, is the fungi you're referring to like arbuscular mycorrhizal fungi? Is that what's most related to crop production, right? If I'm not mistaken.
Well, I'd say it's a very important part. One of the things you do have to realize is that we have a lot of crops that should not become mycorrhizal, and it may actually be detrimental to those very early successional plant species like kale and cole crops, mustards, those broccoli, cauliflower kinds of crops. They shouldn't become mycorrhizal. You don't want to be putting mycorrhizal spores into the soil around their root systems because they're going to join up with some other plant and potentially suck the nutrients out of your early successional plant species into the other plant species. And that's not what you want when you want to be growing broccoli. You don't want to see your nutrients ending up in the sagebrush across the road. Um, so you do have to understand some of those requirements, and it's really easy to go find out if
Mhm.
your crop should be mycorrhizal or shouldn't. So starting with the intermediate productivity grasses and vegetables, so like most lettuces can tolerate being mycorrhizal if they need it. They'll promote the mycorrhizal colonization. If not, they won't put out the exudates to get those spores of the mycorrhizal fungi to grow. So the plant actually has a great deal of control on whether it will become mycorrhizal or not. So very important to get the mycorrhizal fungi around the root system, in the root systems of plants that need it. So most of our vegetables, most of our grasses, all of the shrubs, all of the trees require mycorrhizal fungi, or they're not going to be able to grow very well. And they'll probably be taken out by disease or pests because they're too stressed. They don't have what they need. So saprophytic or decomposer fungi are also really important
Mhm.
because the plant is putting out these exudates to purposely grow those fungal species that are going to benefit the plant. And one of the benefits is control of pH. When you have a strictly bacterial dominated, aerobic bacterial dominated soil, you're going to have an alkaline pH. And for most of our crops, that's a really, really high alkaline pH is not going to promote production. Because that's the most common form of nitrogen under high pH levels will be nitrate. Nitrifying bacteria require soil that is alkaline so that those enzymes that will convert NH4, ammonium, into nitrate will be able to function. And so those bacteria, weedy species, flourish under those conditions. So we as growers need to get the fungi back into the soil because fungi produce organic acids. And that means the pH is going to start dropping. how far do you want to go in the, what's the right pH for my crop? And for most of our vegetables, it's really close to a pH of 7, maybe 6.5, 6.0. That's where you want to maintain it. And the only thing that's going to maintain that for you is to have the right ratio of fungi to bacteria. Fungi are going to keep the NH4 as NH4. And that's a soluble form of nitrogen that your plant can take up. And in fact, most of our vegetable crops, most of our highly productive grass species, all of our row crops really require NH4 more than they require NO3.
Gotcha.
So you put out a nitrate fertilizer, what are you promoting? Something you don't want. You don't want those weeds. So get this nutrient cycling system back in place, make sure that you have the right balance of fungi and bacteria, and your plants are going to grow crazy. You're going to get so much increase. Most of the time, we don't talk to people about increase in productivity because they've got to get the right biology going. They've got to get it balanced. And if they do, they can get some amazing increases in yields. We've had scientifically replicated studies where we're showing somewhere around 1,200% increase in yield in one growing season from applications of the proper biology. Well, sometimes people are only getting 30 or 40% increase. Okay, they still are very happy about that. So it's up to you as a grower. If you put a lot of effort into this, you're going to get rewarded. If you only want to put a little effort into this, okay, you'll get you'll get a decent yield increase. So it's up to the grower to decide what they really want to do. And it's like when we go back to, should you be organic or should you be permaculture or should you be, um, bringing back the biology? It's up to you to, what are you comfortable with? What's the kind of equipment you like to use? Because we never go into somebody's operation and say, oh, you better sell that tractor. You don't have any more use for it. And you've got to go buy this kind of tractor. Not the case. We can adapt all of the equipment that people already have into what we need for getting the biology into the soil and maintaining the proper biology around the root systems of the plants for the next, billion years. And then we'll stop destroying soil. We'll build soil. It's really easy to build massive amounts of really good soil in the course of a year, 2 years, 5 years. You'll be selling that organic matter to other people so that they can repeat your success.
Gotcha. One quick question, like with arbuscular mycorrhizal fungi, is that like a uh, endomycorrhizal fungi, or does that have both like endo and ecto as part of the
Yep.
profile of that fungi? That's one.
Again, you've got to go back to the plant that you're growing, and you need to find out if it requires the endomycorrhizal fungi or the ecto. And probably the easiest way to generally remember all of this is that early successional plant species are all going to, the very youngest or the very, beginning in successional systems, no mycorrhizal fungi at all needed. When you get to the vegetables and most of our pasture crops, they need the endomycorrhizal fungi. So the vesicular, arbuscular mycorrhizal fungi, and a lot of people have taken to calling them the AM fungi, the arbuscular mycorrhizal fungi. I don't really care what you call them. It's their function I want to know. And are they doing it? Have we promoted them and made them comfortable and got them growing on our root systems? Because the mycorrhizal fungal hyphae go out much further than the root system of your plant does and are much faster and do more energetically better for your plant to have their nutrients come through the mycorrhizal fungi. So when we're talking about vegetables and pasture and row crops, those are all going to be VA mycorrhizal. species. When we get into some of the shrubs, deciduous trees, deciduous kinds of plants typically still are colonized by the vesicular, arbuscular, and mycorrhizal fungi. So you can use the same inocula for this whole large part of your production. When you get into the conifers, the evergreens, those are the ones that require the ectomycorrhizal fungi. And it is interesting that people have that when they start studying things like Douglas fir or cedars or different kinds of conifers, those plants actually go through a phase where they are endomycorrhizal, and it's a pretty good probability that those plants have to have the vesicular, arbuscular, mycorrhizal fungi for the 6 months to set the stage in the root system so that ectomycorrhizal fungi can come right along, colonize those root systems. So, I hope you're catching here's some interesting data, has to be replicated, has to be proven over and over and over until we're going to accept it as truth. Yeah, truth requires a lot of replication. And so, isn't it interesting that this might be the case, but we need to be doing more research on that to establish if we have to get those plants endomycorrhizal first, and then you've got the colonization sites for the ectos.
Gotcha. Well, you mentioned a few times about depletion of nutrients in the soil. I got this example from I forgot the author's name, but the book was like Teeming with Microbes. I'm pretty sure you know the author's name.
Jeff Lowenfels.
Yeah, Jeff Lowenfeld, and he mentioned like if you look at the world as an apple and you kind of shave off basically 70% of the surface of the apple, that's like the ocean, and then you take off I forgot, he mentioned like 10% or 15% of the land that's not farmable for crops, and then the rest is like large percentage of the rest is like basically huge metropolitan cities that are built on very fertile land, and like the only thing you have left over is basically like 5 to 8% of the earth's like land surface that's able to be farmed for crops. Do you feel like there is a danger of soil basically being depleted to the point of like not being able to farm anything in the near future, like in your lifetime, for example?
Yeah, I really worry about my children and how are they going to have enough to eat considering human beings keep multiplying. We're spreading further. We're removing more and more of high fertility soils from production because they're at the edge of cities. It is very worrisome. The rate of desertification on the planet is frightening when you go back and look at it because we're destroying faster than we're building.
Mm,
Well, the good news is that we can recover that within 1 year. We can recover vast acreages as long as we have the organic matter, as long as we can get the biology in there. We can recover large spaces, large areas, um, and get it back into production and start producing good food that's got all the nutrients in it for human beings and animals to stay alive. But we've got to find the will. We've got to stop ignoring those people who came back from World War II and very rich companies, very much in control in many ways of our government. They came back from World War II because World War II stopped a full 2 years before anybody thought that it would, because we dropped the atomic bombs on Hiroshima and Nagasaki.
mm.
Well, that ended things way too soon from these uh, war materials that had already been produced. What are they going to do with these mountains of TNT? Well, that's a fertilizer.
You got to save it for the Russians, man.
And, and so they
I'm
started
repeating myself,
that.
so no insult for anyone from that area.
So um, these big chemical companies started putting big ads into all the big newspapers saying it's our patriotic duty to use these, well, I put in toxic chemicals, because those inorganic fertilizers are going to be killing the organisms in the soil and making it impossible to grow your plants without those inorganic fertilizers and pesticides. So that's where we started down this road of using toxic chemicals. And because there was so much money involved, every single university and many colleges got right into the pockets of these large corporations. And our curriculum in the universities promote that kind of agriculture. Well, that's agriculture that is turning our soil into dirt and turning our dirt into deserts.
Hey everyone, thanks for checking out this podcast. If sourcing high quality food is something you're interested in, but definitely find the subject matter confusing, check out my book on Amazon titled Anti-Factory Farm Shopping Guide. It's a very easy and non-technical read that's beautifully illustrated and comes with a comprehensive video series and other extended learning material. The book, in a very simplified way, breaks down the difference between caged, cage-free, free-range, and pasture-raised meats. It'll cover how to avoid GMOs, source high-quality water, fish, supplements, and many other related topics. Thanks again for checking out the podcast, and when you have a second, please check out Anti-Factory Farm Shopping Guide by Eugene Trufkin on Amazon. But how do farmers get convinced to do this if at the end of the day it hurts their bottom line because they're not able, they just have to keep reinvesting more and more into inputs by having to do that system?
Right.
I mean, isn't
And
that
it's,
like very obvious from the get-go that it's not
well,
going
you got to go back in time and ask, why is it at the end of World War II that all these agricultural fields were lacking the nutrients that the plants needed? When you put on nitrate fertilizer, woohoo, your plants took off. How can that be? It's because we had already destroyed the biology in that soil. And so how did we do that destruction? Well, go back through World War I, same kinds of problems with chemicals starting to be applied. But that's not the real problem. Go back into the late 1800s when the mechanical tractor was invented over in Australia. Thank you, Australians. This is all your fault.
those guys?
Yeah, those guys, those Aussies, you just, I don't know. They should have to pay for it all. So,
Trump will get him to pay eventually.
right. Yeah, which millennium is that? So the concept of tractors came over to the United States and people started using them because in one day you can do what a herd of people have to take days in order to till and get everything all smoothed out and get, pull all the weeds, prepare all the beds. With a tractor, you can go out and you can put on that inorganic fertilizer in an hour, what it used to take 2 or 3 people to all day or perhaps all week in order to get the fertilizer out. So of course farmers are going to use that because they save salary money. They save wear and tear on all those hand pieces, and they are now, it's one size fits all tractors. And every time you till, you are killing 50% of the biology in your soil. So you can see how rapidly in the course of one growing season, you've pretty much, well, how many times have you tilled in the course of that first growing season? Probably a minimum of 4 to 5 times. Okay, so if you started out with 1 million units of microorganisms and you drop those by 50%, and then you drop that by 50% again and 50% again and 50% again, come the next spring when you come out to start doing that all over again, you're no longer up here at 1 million, you're at 10,000. Okay, and now you're going to wipe everything out. So next year you're starting at 10.
Mm-hmm.
So you can see how rapidly you go from highly productive soil into dirt. Now, what are you going to do to put the nutrients out there? And it just is the common way of dealing with growing plants. And we've got to get people off of drugs, because isn't that what we're really doing? We're supplying the drugs and patting them growers on the back for being hooked on drugs. So get off of it. What do you have to do? You got to put the biology back in. And that's what we do at Soul Food Web, is teach you how to make your own compost. How do you put your own materials back in so you don't have to be paying anybody?
Gotcha. Well, yeah, I do want to talk about your organization too, because I want to give some good insight on what a person can do if they want to kind of just grow their crops in their backyard. I feel like a lot of people in the US do have the space necessary, and it's not that much space necessary just to feed like yourself and your kid and your wife, for example. But before we go on, I do want to cover a topic like less talked about. And I got turned on to the idea by Joel Robinson, the author of the Wilditarian Diet. And she mentioned like one of the biggest problems with crops these days is actually the fact that obviously they've been genetically selected for breeding over like hundreds and hundreds of years, and they're like already a far cry from their wild ancestors. Like the root of the carrot, or yeah, the carrot started as like a root in Afghanistan, then through 100 years, hundreds of years, it became purple in India. Then hundreds more years, it became red in China. Then 100 more years, it became like white in Turkey, and then a couple hundred years later, it became like orange. And then all of that time, like the anthocyanins have decreased like a tremendous amount. Obviously, they're a potent anti-inflammatory that helps you fight off all sorts of disease. So, what's your take on like the crops that we're already dealing with are already starting at like a depleted nutritional profile as compared to those wild ancestors that they originated from? And then on
Yeah,
top
if
of that, compounded the difficulty of monocropping plus chemical agriculture. You're pretty much just getting like empty calories at the end of the day. And then it's picked unripened, obviously, so it can ripen in the store. The long transportation, by the time you eat it, is probably like 2, 3 weeks old, picked from the root, et cetera, et cetera. It's like, I feel by the time you're eating a lot of these crops, it's like you're just getting like
it's
empty
filler,
calories and that's it,
yeah,
just like
you're
random.
just filling up your stomach and
Yeah.
trying to make certain that you get enough nutrition. And one of the indicators that I always use is to say, where did the supplement industry come from? I don't remember getting vitamins as a child. I never saw commercials for vitamins, and vitamins and minerals. And now today, who amongst us isn't going to go get supplements because we don't have enough magnesium, we don't have enough manganese, we don't have enough iron, we don't have the right kinds of iron, and so we're all taking supplements. Um, uh, uh, I'm 68 years old, so 68 years ago there was no industry that
It was
providing
called eating
supplements.
fruit and
Uh-huh.
vegetables. That was the vitamins and mineral complex.
That's right. Yeah. Here's an orange. You
Yeah.
eat the orange or a grapefruit, and then for plums, or you have problems with your digestive system, you're going to be eating fruits of different kinds. So um, that was always the solution to a lack of nutrients. Go eat something that we know has those nutrients in it, and then it becomes we don't have adequate nutrients, or with genetically engineered organisms. What have they engineered out when they changed the reading frame shift of this piece of DNA to something else? How did that affect all these other compounds that need this amount of DNA read versus that amount of DNA read? We're not getting the nutrition, and there's several papers and more coming out all the time that are showing that we don't have the nutrition in our food that we had even 50 years ago. I remember I grew up in the Twin Cities. We lived in the suburban area, yet we were close enough to big fields that we had gardens and we grew most of our veggies and stuff like that. By the time I was a teenager, my mom didn't do that anymore. She bought frozen everything. So yeah, it's been in this last one or two generations that we've gone down this pathway. And how do we get those nutrients back into our plants? You do have to get the biology back into the plants. So now they're getting all of the nutrients that they should get, but are these crops that we're growing now still deficient in their ability to take up those nutrients? And that's a question that for me hasn't been answered. Um, can we get the same nutrition back into our plants as we had before just by getting the right biology? Well, we can improve it beyond a shadow of a doubt. But are we all the way back? Have we selected for these agricultural wimps that aren't taking up the nutrients so that we will be human wimps?
Gotcha.
It's an interesting question. There's another place that we need a lot more research.
Well, do you shop at the grocery store at all for your fruits and vegetables, or do you grow it yourself? Like, what do you rely on?
I I rely on my organic buddies. So, here in Corvallis, there's a large part of the community that just goes to the co-op, or we go out to Gathering Together Farm, or any one of those places. Um, we eat in restaurants that only get the food from Tom Dennison or Harry McCormick because it's really good organic food. And so we kind of restrict ourselves in where we go out to eat because we want actually full nutrition. We go and buy the organic materials at First Co-op or different markets that have them, and you sort of just close your eyes and take the organically grown because it's the best we've got. Could it be better? Oh yeah. The
Yeah.
organic world needs to start paying attention to the biology. So many organic growers, when I talk to them, they say, well, I've been organic for 5 years, so all the biology is back in the soil. And so I'll say, okay, great, let's take a look. And then they're just blown away by the fact that they're still growing their crops in dirt,
Mhm.
not in soil.
Yeah, I don't know if you're familiar with Dan Kittredge
Yep.
from Bio Nutrient Food Association, I believe. Have you heard of that device they created, the spectrometer?
Yeah, I want them to I was supposed to go out this November and speak at their annual conference, and I was hoping that then I would be able to get a look at their machine and get a chance to test it. And I'll bring some stuff with me that is really horrible and stuff that looks very much the same but is really good,
Hmm.
and test it with their machine so that I can, with confidence, use that. That's I need the scientific data to be able to um, recommend machinery like that.
Gotcha. How do you feel? Do you feel the refractometers are accurate enough? Like they give you a good ballpark of like what's the nutritional value of that crop?
Well, those refractometers only tell you certain things. They cannot tell you about the full nutrition of that plant. It can give you a pretty good idea that, yeah, this is a healthy plant because there's a lot of dissolved solids in the sap that you're testing from, and the sugar level is high. But a really high sugar level can tell you that something's very, very wrong.
Mm. Mm.
A low sugar level tells you that something's really, really wrong. Um,
Be in the middle, like in everything in life, you know?
Right. Yeah. I want my number on this kind of plant to be up around 20.
Uh-huh.
On this kind of plant, I really want it at more like 15. So you have to have a chart of some kind so that you can really interpret the data correctly. And then it's really only relying on sugars and dissolved solids, things like amino acids and proteins in the sap. And I want to know about some of the other things. I want to know what kind of vitamins and where's the calcium and what else can I get from this plant. And I am not going to be sucking sap. I'm going to be eating the fruit. I'm going to be eating the seeds. I'm going to be eating some other part of the plant. So I want to know if the iron and the magnesium and the calcium and sodium, potassium, iron, zinc, all those other things are in the tissues of the plant, the parts that I'm going to actually eat. So I know that I'm getting the nutrition that I need.
Have you ever got into like wild crop, like foraging?
I
Uh,
haven't really gotten into it very much because I've spent too much of my life in a laboratory
mhm.
or going out to the field and collecting soil samples. And
Gotcha.
I, I am so envious of people who have, that um, expertise to be able to go out and forage. I go out and I look for mushrooms, and there's only one mushroom that I know really, really well and can identify it as compared to everything else in the woods, and that's agaricus.
Hmm.
Uh, I don't trust my ability to
You're a risk
identify.
taker in that area.
Yeah, absolutely.
I want to
Because
give props to like the first human beings that actually have to try all these crops just to see what even worked to begin with. You know, everyone's like looking at them from the tribe. It's like, okay, he looks okay. I guess we'll give it another week and see for sure, and then we could all try to eat it. You know,
up and
those guys are
and
the
it's
real heroes. You know.
yeah, those were the real pioneers
Yeah.
trying to determine, where you take just a little tiny nibble, and now your lips start going numb, numb, and your tongue goes numb. And how do you get rid of? Wash it off. Oh, get it out, get it out. I just can't imagine doing that kind of testing for people. Whoa.
Yeah, the old place I lived at, it had just a bunch of dandelion leaves and mint growing like pretty much everywhere. And I thought that was like so cool because I didn't have to do any farming and it just like grew in abundance all the time. And I would just like eat it like freshly picked like off the ground. And I'm like, man, maybe foraging is way easier than farming after all. You know, maybe the
But
homestead
you
was the
need a
hunter gatherers had it right
few.
from the get go. You know,
You
they're
need a
less
few more nutrients
yeah,
than is in mint and what was the other plant?
dandelion.
Dandelions.
Mhm.
That I would get really bored really fast on a
Yeah,
diet of that,
well, I'm not a picky eater, you know, so.
Yep. But like in my yard, I'm on a 135-foot by 80-foot lot, but I've got like 6 fruit trees of different kinds. I have cherries, the bings, and the sours. I've got mint all along one side. I've got marjoram and lilac, just massive amounts of foods and herbs because I want to know what quality those herbs are
Mhm.
when I use them to make myself feel better, to calm myself down, or get rid of a runny nose, or, I need to get rid of inflammation, whatever. So you want the full food web, the proper balance of bacteria and fungi for those crops. And so you grow bumper crops. You can get away with not having as large a garden because one tomato plant is going to provide a family of 4 more tomatoes than they can possibly eat.
Mhm.
So one normal size, beefsteak kind of tomato and the other little cherry tomatoes. The problem here is the deer come along and eat them. So you got to do something about getting up a deer-proof fence. And
Yeah, I was
I've
just gonna say it's pretty easy to set up like a net environment. They pretty much stay.
Yeah, not with these deer. They're big enough to just run right over it. And I've watched the big bucks with the horns and everything, get caught up in the netting around my
Mm,
garden,
I see.
and they just rip it all out. And
You're living in Minnesota still, correct or no?
nope, I'm in Oregon.
Oregon. Okay, gotcha. Okay. Well, regarding the next topic, a lot of times people see like farming these days, and they see these huge, like hundreds of acres and acres of farms, and they think, you know, like, oh, I can't possibly do this at home. I have like a small little patio, and I also need that much room to just even have 2 pounds of carrots, for example, like per year, you know. So, like for my research, it's like you don't need that much room actually to grow like a lot of vegetables. From my understanding, you can grow about like on average, of course, it varies on a bunch of variables, as you've mentioned just during this podcast today, but about like 15,000 pounds of vegetables per acre per year on a well managed soil. So, for my calculation, just 1/15 of an acre, which a lot of Americans have access to, will produce for a family of 3 about, I forgot the exact numbers, I'll have to look at it, about like uh, 250 or 300 pounds of vegetables, like freshly picked from the ground with your own standards, no USDA or organic certification required, or like the million other certifications. You know exactly what went into that soil, et cetera, et cetera. So can you kind of go into the details if a person would want to do that, like the steps they would have to go through? Like, I know sometimes people are worried about like chemicals being used on the with the previous owner of that house, possibly on that land? Is that a worry, or like what steps should they take to kind of get into that?
Yeah, and in most parts of the US, anybody selling property has to call out the use of heavy metals or where there's a potential problem like that. So you want to be informed. You would want to specifically ask the real estate agent whether any heavy metal materials had been applied, and if so, where. Copper sulfate is a common fungicide that is used on berries and on fruit trees, so in orchard situations. So you'd kind of like to know if these people had, the people before you, had been applying any of those chemicals, and they're supposed to be honest about it, you know, because you don't need to go ballistic about it. Okay, you use copper sulfate on the tree, on the berry, on the the fruit trees. What did you use anything in particular? Oh, so Roundup over here. Okay, we know that Roundup is going to tie up nutrients in the soil, so they are not available to your plant. How do you get rid of that Roundup? How do you get rid of the copper sulfate? What do you do specifically? And in almost every case for these kinds of toxic chemicals, you want to get some really good compost that's got all these organisms in it. Please check it with a microscope. And we are training people at Soil Food Web Incorporated and Soil Food Web School, Soil Food Web School, um, to do those kinds of assessments. So you can find a soil food web technician who will do the microscope work for you. And typically they're going to ask you to, when you stop by with your sample, they're going to ask you to come on in. You sit down and you watch what the biology is in your soil. And you can see that they're not fooling you. They're not adding something. They're just putting water and the sample, mixing it up really well, putting a drop on the microscope slide. Now there you are. That's what's in your soil. And you can tell right away, look at all those flagellates running around. Well, maybe you didn't know they were flagellates, but your technician will tell you what they are. And you can get a really good reading on how good your soil is or whether it's actually dirt. And if the people before you have used a lot of chemicals, you're probably going to only be seeing bacteria and not the good bacteria. So that's where you need the compost. So bring a sample of the compost you're thinking about buying and have a sample run by that local technician. And if the compost doesn't have any biology in it, then it cannot be compost. And they should not be calling it compost if they don't have any decent biology in it. So you want to search around until you find a good compost, or you just say, forget this, I'm going to put together a 4.5-foot tall wire circle, maybe about 5-foot diameter, and I'm going to put organic material in there. I'm going to let it compost. It takes a year if you're going to be just letting it sit there and doing its own thing, and you're going to cross your fingers that it doesn't go anaerobic. Or you can have a compost pile done in 21 days if you follow our directions that are, you've got to have 15 days to devote to making that compost so you're sure to be home the whole entire time so you can turn it on time. You can water it, whatever needs to be done. And so now you've got all the compost you need, certainly for a backyard operation. You might even end up giving your neighbors some of that compost because you've got more than enough. And then you just make another batch, and all your neighbors love you because their tomatoes went from something that was just terribly disease ridden to, wow, in a week it's come back and we got tomatoes on it. So you want to go in first and decide where you're going to be putting your garden. What are the limits? And you probably, for the first time ever, especially if you've had people before you compacting the soil or using toxic chemicals, you're going to want to till that soil for the last time ever. You till that soil. Before you till, you put in a good 1/2 inch, maybe an inch if you've got it, of your compost and get that organic matter mixed as deep as you possibly can into the soil. You want that, all of that good organic material to be all mixed in that top 18 inches or 24 inches, whatever rototiller you've got. And it chews all of the organic matter up. So all the bacteria and the fungi present in that compost, they're just going, oh, wow, this is a great place to live, and start to multiply very rapidly. They're all aerobic organisms. So you're building structure. You're going to make it a great place for your starts or for your seeds to be put in. You probably want to learn how to make a compost tea or a compost extract. So you take a little bit of your compost and you just rinse it over and over and over again. So you get all the good organisms off the surfaces of the compost and into the water. And good compost should have lots of humic acid in it, so your water has that nice, rich, dark brown color. And so where you're going to put in your furrow to put down your carrot seeds or onion or whatever you're doing, you want to put a drizzle of that compost extract right where you're going to lay the seeds. And then cover them up. You're going to want to make certain that all your rows are marked and you know what's in there. You might want to be putting in mycorrhizal spores if you're growing plants that require mycorrhizal colonization. But it is one reason why you might want to keep your brassicas and your coles and your kales and your mustards in a separate part of the garden, because they don't want mycorrhizal colonization, whereas your other crops do require that mycorrhizal colonization. So, put out a compost tea that has the mycorrhizal spores in it when you're putting in your seed. So the instant that that seed germinates and the roots come out, it will get colonized by the mycorrhizal fungi. And then you want to be applying a compost tea right about first true leaf stage, and then monthly through the growing season after that. So there's lots of come to our website, Soil Food Web School, and go through and look at all the information we have on the equipment. We've tested everything that we recommend, so we know it works and we know how it works. And so you can discuss that with our consultants if you want.
Is it good bet like if you dig like a foot into the soil, for example, you see like a lot of earthworms? Is that a good bet that there isn't a lot of like chemical residue in that soil?
Yep. But in addition of all that compost, all that good biology growing in the soil, that's decomposing everything that you want to worry about. Even if you had lead or if you had copper sulfate, all of that sulfate is going to be converted into organic matter. The copper is going to be put back in the structure of the humics and the fulvic acids, so it won't be able to be taken up by your plant. So you balance everything by having this biology doing its job and sequestering all of those toxic things and making sure that the nutrients that your plant does want, your plant wants a little bit of copper, not a lot, but it needs enough, not too much, not too little. And so let the plant and the organisms be the determinants of whether the plant is getting what it needs. Not too little, not too much.
Yeah, and for the listeners, some people are like, I'm worried about these chemicals in my backyard. So first of all, like conventionally farmed crops are dosed with chemicals like almost daily. So you're already getting that at whatever supermarket. It's not like you're not being exposed to it. You're already getting that plus like a myriad of other biocides or whatever they're using in that specific operation. For sure.
Yep.
That's like guaranteed and included with the price and tax. Okay.
That's right.
Just,
You're getting this for free. You don't want a digestive system that actually works, do
yeah.
you?
No, that, well, maybe the people that are making the money off the drugs for people with digestive issues don't want that. So that's for sure.
That too. Yep. That whole pharmaceutical industry. Oof.
Okay, well, I guess kind of looking into the future, hypothetically, like Elon Musk and Jeff Bezos, they're trying to colonize Mars. I don't know your stance on like hydroponics or GMOs, but do you feel like those kind of technologies will thrive at least during the first settlements and on other planets? Or how
Yeah, I
do
don't.
you feel about actually raising crops on other planets? I don't even know where to start with that one.
Yeah, we're going to have to do selection over the next however long it takes to um, develop plants that have utilize the wavelengths of sunlight that arrive on the surface of Mars. And I all the movies where people are living on Mars and growing potatoes and all of that stuff. It's like, I don't think so, guys. I don't think it's that
You telling
easy.
me Matt Damon in The Martian wasn't able to grow those potatoes?
No
Yeah,
way,
he really
Jose.
thought it was possible. He said he was a
Yep.
master botanist.
They forgot a few things, or they didn't explain that they had already selected somehow for potatoes that use those wavelengths of light coming down to the surface of Mars. Certainly, they got parts of it right, where making compost out of your own poop, yeah, that's entirely doable. Once you've had all of that decomposed by the microorganisms, it's not human manure anymore. You're dealing with organic matter. And if we can't, if we told people what the likelihood of you walk outside, you pick up a handful of really good soil, was that once upon a time poop from an animal? I can just about guarantee you it was.
Hmm, hmm.
But it's not poop anymore. It got changed into this really good organic matter. So we need to, develop plant species. I'm not certain that genetically engineering it is the way to go, because you never really know what you've got. How is that DNA going to be read once you've put it into the genome of that plant? I think it's way easier to select for plants that do very well in the sunlight that you're going to be getting on Mars or Venus or wherever. Otherwise, we're going to have to be trucking along our normal wavelengths uh, lights, and we will always have to grow crops in greenhouses. You won't be able to get them outside on those vast plains of sand or whatever. And I've never heard anybody say what the fractions of sand, silt, and clay are in these soils on Mars. Do they have clay? Do they have the really smallest particles? Do they have the silt, the next larger, and sand? If yes, then there's a much greater probability that we'll be able to grow plants on Mars
Hmm.
out in the fields. Um, so, interesting question. Certainly, hydroponics will be
Yeah,
used on other planets. Whether we'll be able to grow things outside, that remains to be seen.
yeah. I figured that hydroponics was actually the one place where that kind of technology could really excel. So what's your take on hydroponics in general, in
People
terms of?
need to stop. Well, it's just like with the chemical agriculture. Um, they've tried to they are pretending that you have to do chemical agriculture in a greenhouse. Absolutely not. It's very easy to set up the biology in the hydroponic system, and all you have to do is maybe once a week, depending on how much plant material you've got in the troughs, once a week, you're going to be adding the right amount of humic acid, and that humic acid circulates amongst all those root system. And that's what the microorganisms, bacteria and fungi, are taking the all of the nutrients, the nitrogen, phosphorus, sulfur, magnesium, calcium, sodium, potassium, iron, zinc, all those nutrients are being pulled from the humic acid. Perfect way to deliver your required sets of nutrients for the bacteria and the fungi to take up. Then you got to have protozoa and nematodes and microarthropods and earthworms around the root systems. It doesn't matter that it's water, because everything in soil actually happens in the layer of water on the surfaces of sand, silt, clay, rocks, pebbles, the organic matter, and all of that. So you now have the predators that eat the bacteria and fungi. The plant gets what it needs. The plant grows. Human beings get the nutrients that they require. The excess go back into the compost piles. So around the root systems of all your starts that you plunk into that little container of soil that the seed was planted in, and now the plant's growing, the roots are going out into the water. You just start the next cycle over again. You can grow bumper crops of plants in any kind of greenhouse using an organic approach. If is this enough soil to be able to call this organic agriculture? I think so. As long as you've got the right biology, you don't need a lot of actual soil. You need a little, but everything else can be done in those in the liquid systems. Whether it's your plants are floating on top of the water and the root systems are going down into that tank of water below, you just have to remember to feed the nutrients into the system in a form that the bacteria can and fungi can take up. And then you're not harming your plant. You're not destroying the nutrient cycling system that Mother Nature has developed.
Yeah, I guess agriculture is still kind of stuck in the same like problem and mindset that the fitness industry or health industry is stuck in, and that it's easier to always treat symptoms versus changing the belief system that led to all those problems to begin with, obviously. So, and then obviously
Yep.
environment, et cetera, et cetera. So totally understandable. So
Yep. You perfect timing to bring that one up. Thank you.
yeah. So what kind of courses are you offering these days, or are you offering like any other type of services that uh
We have the foundation courses, which is the explaining the theory about how to use the biology, how can you make your own compost. So we go through all of the steps necessary, the things you have to think about. We talk about some of the equipment that people have for making compost, small scale, it's a trowel and a pitchfork and a rake. Um, something to carry water in, or hoses and things like that, the wire screening to put your compost pile in. And then once your compost is made, well, you're going to have a microscope to determine exactly what's in that compost. So you'll be buying a microscope most. So we teach you to use that microscope and take pictures so that you can work with people at long distance.
hmm,
You don't have to both be using the microscope in the same room. So for your comparisons, you're just doing the camera work. And we've done a lot of work on figuring out how to get a camera that you can compare with everybody else. It's the same field of view, same magnification throughout the whole system, the microscope, taking those pictures and doing those comparisons. So we can um, do quizzes from long distance. You can be looking at your sample that you sent to somebody the next state over because there's no one closer to you, but you can be looking at what they are seeing on their microscope at the same time they're seeing it. So you're getting your information back instantaneously on what's going on. Um,
hmm.
so teaching people how to make compost teas and compost extracts, working with the microscope. Then we train people if they want to be trained to become lab technicians and do the microscope work for everybody else in the town. So we have lots of people being trained that way. And then we have consultants that we're training. And it is a 2 to 3 year process to become a consultant. There's a lot of information, there's a lot of hands on. They have to be able to do this themselves so that then they can teach you how to make compost and how to make good compost teas and extracts, and how to go through the process of converting your dirt back into soil. And we are working with a lot of people on their particular projects. So we have, working with small scale, working with large scale people. We can span the gamut. And really, there's so much land on this planet that has to get fixed that there really isn't any need to compete with anybody else. There's so much work that has to be done. And at least everybody is recognizing that biology in the soil is really the cure for all the damage that we've done to land. And we can bring deserts back into full production because we're holding on to every drop of dew, every drop of water that gets anywhere near. We're going to be able to sequester and hold that in the soil. We look at the fact that, even 5 to 6 years ago, agronomists were saying You can't increase the percent carbon in agricultural soil. It's not possible. You can't do it. And
Isn't that what
working with
fungi does, is bring the carbon into the soil? What are you
exactly,
talking about,
it's
man? That's
yeah,
not even a master biologist, and I know all that stuff.
right. And it's all these agronomists that had no clue that there's supposed to be life in this dirt. And if you don't have that life, you can't possibly sequester carbon. But we can. There's a number of people who are starting to show this. We're doing the work that David Johnson at New Mexico State University has been doing. He is showing that as you increase that fungal component in your soil, you increase sequestered carbon.
Because of the glomalin, right? The
There's a number. Yeah, the glomalin is not the only glue that microorganisms make. Fungi produce lots and lots of other kinds of glues, not just the glomalins, but that is the basic concept. And the other thing you have to think about with fungi are when fungi grow, that growing tip is just one single layer of cells thick.
Mhm.
But as that growing tip moves on, and now you're looking at a mature cell that's maybe 10 or 20 cells away from that growing tip now, that fungus has been putting down carbon on the inside of that hypha to strengthen the walls so that if a microarthropod comes by and tries to eat it, it can't take a bite out of it. And so the microarthropod just keeps going, and that hypha is going to remain intact. Well, the older that fungal hypha is, the thicker and thicker that cell wall becomes on the inside, not on the outside. So the fungal hypha stays the same uniform diameter, but on the inside, it's getting thicker and thicker. And that's all carbon. It's almost completely just a carbon compound on the inside of the walls. So this is where people are going from 11 tons of carbon being sequestered per acre per year. 11 tons. If we had, a small proportion of the United States where everyone was sequestering that much carbon, we'd be able to get rid of the elevated CO2 in the atmosphere in a very short period of time. I mean, you can do back of the envelope calculations and figure it out for yourself, but that's the way we have to do this. We have to get all these organisms back into the soil. So you're growing crops at an incredible rate. You're producing the organic matter that you have to make the compost. You're growing the organisms that need to be in that soil so you can make the massive amount of organic matter so you can make more compost, so you can have more organisms, so you can have bigger yields, it's a positive bootstrapping system. The the thing we're going to ultimately have to take care is that we don't put too much carbon back into the soil. We'll go to that opposite extreme. I just want to get there before Mother Nature gives up on humanity.
Gotcha. Gotcha. Okay, cool. I had one more question, but I totally spaced out on it. Fortunately, I'm probably going to forget like 5 hours from now, and I'll do something. But
Yep.
yeah, thank you again for being on the show, for being a huge role model for me. I've been trying to do a lot of research on. For me, this whole entire journey started with I actually grew up on an off-grid farm in Ukraine. So when I came to the U.S., like I just thought everyone grew food the way we grew food there, like without chemicals, and it's just animals were always outside 24/7. We had a variety of animals as well. Uh, and then I think 4 years ago at this point, I ran into Paul Chek's uh, Nutrition, the Dirt Facts video, and he talked about the comparison between biodynamic farming plus like industrial agriculture. And I'm like, oh man, you're telling me those 50 eggs I was buying at Costco for $1.50 weren't raised all on pasture on just a species specific diet without grains. And it became so confusing after that in terms of reading past all these labels, what's cage free, free range, pasture raised, and the myriad of variables in between each one of those categories. So you're a huge light tower for me in terms of understanding the soil food web a lot better. So I appreciate the tremendous amount of work and criticism you have to overcome to be able to kind of keep your message alive, and that way I can learn from it and stuff like that. So
Yep, I'm really grateful for all the people at Soul Food Web School that are helping with all of this. They're amazing folks, and so yeah, go and take a look at our website.
Do
Um,
you have like
s-
anything else you want to add before we close it up?
oh, I could keep going for another couple days, so this is probably a good place to stop.
Gotcha.
Yep,
Okay.
and thank you so
Yeah,
much for allowing me to come and give the talk, give this chat
cool.
with you.
No, thank you. It's great. It's great to meet you as well. Thank you for being
Yep.
you.
Okay. Have a good day.
Have a good one, guys.
Yep. Ciao.